Hi guys, my name is Srikar and welcome to Let Us Study channel. Today we are going to learn about the history of periodic table. First, who is Daubeney and how did he classify his triads? Then who is Newland and how did he classify his law of octaves? Then who is Dmitri Mendeleev and how did he classify his periodic table? Then here comes the man of the periodic table, who is none other than Henry Moseley, who is the creator of modern periodic table which is in use till now. So let's get started. The first thing is, who is Daubeney? Johann Wolfgang Daubeney studied as a pharmacist at Munzburg in Germany, and then he studied chemistry at Strasbourg. Eventually, he became a professor of chemistry and pharmacy at the University of Jena. Daubeney made the first observation on platinum as a catalyst and discovered similar triads of elements, which led to the development of the periodic table of elements. The law of triads. In 1817, Johann Daubeney noticed that the atomic weight of strontium fell midway between the weights of calcium and barium, elements possessing similar chemical properties. In 1829, Johann Daubeney placed various groups of three elements into groups called triads. One such triad was lithium, sodium, and potassium. Triads were based on both physically as well as chemical properties. The next topic is about Newland. John Alexander Rayner Newland was born in November 26, 1837, London, in England. He was an English chemist whose law of octaves noted a pattern in the atomic structure of elements with similar chemical properties and contributed in a significant way to the development of the periodic table. And what was his law of octaves? Law of octaves in chemistry, the generalization made by the English chemist John R Newlands in 1865 stated that if the chemical elements are arranged according to increasing atomic weight, those with similar physical and chemical properties occur after each interval of 7 elements. But his law was applicable only up to calcium. After calcium, his law was not applicable. The next topic is, who is Dmitri Mendeleev and his periodic table? Dmitri Ivanovich Mendeleev was a Russian chemist and inventor. He is best remembered for formulating the periodic law and creating a far-sighted version of the periodic table of elements. Then how did Mendeleev arrange the periodic table? Mendeleev arranged the elements in order of increasing relative atomic mass. When he did this, he noted that the chemical properties of the elements and their compounds showed a periodic trend. Now we will see limitations and drawbacks of Mendeleev's periodic table. The first one is, he could not assign a correct position of hydrogen in his periodic table, as the properties of hydrogen resembles both with alkali metals as well as with halogens. And the second one, the isotopes of the same element will be given different position if atomic number is taken as basis, which will disturb the symmetry of periodic table. And the third comes, the atomic masses do not increase in a regular manner in going from one element to the next. So it was not possible to predict how many elements could be discovered between two elements. Now let us discuss some of the drawbacks of Mendeleev's classification. The first one comes, for placing the elements in proper groups, the order of the elements according to atomic mass was reversed in certain cases, such as he placed iodine, whose number is 127, after tellurium, whose number is 128. Then potassium and nickel, whose numbers are 39 and 58, after cobalt, whose number is 59. Which is against his periodic law but correct according to properties. The second drawback of Mendeleev's classification is, Mendeleev's periodic table does not provide a clear idea about the structure of atom. The third one is lanthanide and actinide have been assigned places in the periodic table, which is against the periodic law. The fourth one, alkali metal and coinage metals Cu, Ag and Au, which are copper, silver and gold, which differ widely in properties, are placed into the same group. The fifth one is there is no separate position for isotopes in his periodic table. Then the last and sixth point is the change in atomic mass of two successive elements is not constant. Hence, it is not possible to predict the number of missing elements by knowing the atomic masses of two known elements. Let us see who is Henry Moseley and what made him to discover about the modern periodic table. Henry Gwyn Jeffreys Moseley was an English physicist whose contribution to the science of physics was the justification from physical laws of the previous empirical and chemical concept of the atomic number. This stemmed from his development of Moseley's law in X-ray spectra. Now, what made Henry Moseley to discover about modern periodic table? In 1913, he used self-built equipment to prove that every element's identity is uniquely determined by the number of protons it has. His discovery revealed the true basis of the periodic table and enabled Moseley to predict confidently the existence of 4 new chemical elements, all of which were found. Now let us see the main concept, which is modern periodic table, which was modified by Henry Moseley from Mendeleev's periodic table. First, let us see what is modern periodic law. Modern periodic law states that properties of elements are a periodic function of their atomic number. Here, Henry Moseley took the periodic function as atomic number, whereas Mendeleev took periodic function as atomic mass. Now let us see what are valence electrons and what is valency. You can observe that the number of valence shell electrons increases by 1 unit as the atomic number increases by 1 unit on moving from left to right in a period, but remains same when gone through a group from top to bottom. And at last, in valence electrons, I want to say that valency is determined by number of electrons present in the outermost shell of its atom. Now let us see what is atomic size. Atomic size refers to radius of an atom. It may be visualized as distance between center of nucleus and outermost shell of an isolated atom. For example, atomic radius of hydrogen atom is 37 pm, which is picometer. Here 1 pm, which is 1 picometer, equals to 10 power minus 12 meters. Now let us try to learn about metallic and non-metallic properties. We can see on the screen that metals like sodium and magnesium are on left hand side and non-metals like sulfur, chlorine are found on right hand side. But did you observe a zigzag line in between them? Yes, that divides metals and non-metals, and there lies semi-metals or metalloids. Borderline elements like boron, silicon, germanium, arsenic, antimony, tellurium and polonium are intermediate in properties and are thus called metalloids or semi-metals. Now let us try to learn about electronegativity's impact on nature of oxides. As the trends in electronegativity show, non-metals are found on right hand side of periodic table towards the top. As you can observe on the screen, right top. These trends also help us to predict the nature of oxides formed by the elements because it is known to us that the oxides of metals are basic and that of non-metals are acidic in general.